In this video, we're going to name covalently bonded compounds and then also acids. So covalent compounds first. And remember, covalent bonds, we're actually sharing electrons between the atoms in the bond. So the bonding electrons are shared between the two atoms. And they don't have to be shared equally. We'll actually talk about that also this week. But they are shared. So the bonding electrons, the bonding electrons are shared between the two atoms in the bond. So we're not going to have charged atoms, right? There's no cation, there's no anion. I can't say cation first and anion second because that doesn't exist, right? I don't have charged atoms. No ions. I also can't say that the number of electrons gained is equal to the number of electrons lost when we're writing compounds, right? When we're writing the chemical formula, because I'm not doing that, right? We're sharing them. We're not gaining or losing electrons. So when we name these ones, we're actually going to use Greek prefixes that go in front of the number of each type of atom I have. So be careful. When we use the Roman numerals for our variable charged metals, that told us the charge on the atom, right? That the number of atoms. When we're naming covalent compounds, we're actually going to use a prefix that tells us the number, not the charge, because again, they're not charged, right? No ions at all, right? We're sharing electrons. I do want to add that molecules, just that term, because I use it a lot, are covalently bonded compounds. So molecules, these are going to have covalent bonds. So even something that's diatomic is technically not a compound because it's atoms of the same element, but there is a covalent bond between them. So we could call water a molecule. We can also call it a compound, but we can call it a molecule because the bond between them is covalent. And again, it typically forms between a nonmetal and another nonmetal. It doesn't have to, but for us it will. So these are going to form between a nonmetal and another nonmetal. Eventually, I will mix up ionic compounds with molecules, right, with covalently bonded compounds, and you'll have to name them, and it's going to be a different set of rules, right? If it's covalent, I just said we're going to use Greek prefixes to tell us the number of each type of element that we have. If it's ionic, we don't do that. So kind of your first thought when I give you a compound is it covalently bonded or is it ionically bonded? Because again, those are going to be a different set of rules. So for us, we're going to look, is it a nonmetal and another nonmetal? Just watch out for polyatomic ions, right? The bond within a polyatomic ion, right, in ammonium, right? Ammonium is one of my polyatomic ions. The nitrogen has a covalent bond to 4 different hydrogens. But then if ammonium bonds to chloride, then the bond between those is going to be ionic because it's between charged atoms. Okay, our Greek prefixes. So these are pretty straightforward. 1 is going to be mono. 2 is going to be di. 3 is going to be tri. 4, tetra. After this, it just follows geometric figures. So penta, right? A pentagon is a geometric figure with 5 sides. We're just going to go up to 10. 6, hexa. 7, hepta. 8, octopus has 8 legs, right? Octa. 9, nona. 10, deca. Right? A decade is 10 years. A decimal place is a tenths place, right? So you do need to memorize these. I think they're pretty straightforward though. Mono, most people know is 1, di, tri, those seem pretty straightforward. The ones that folks tend to struggle with are hepta for 7 and then nona for 9, just because we don't use them so much. But these are going to be our Greek prefixes. So kind of how we're going to write it is we're going to have a prefix that tells the number of atoms of the first element. And I can't say of the cation because I don't have a cation, right? I can't say cation first, anion second. So honestly, and I'm going to give you a rule later on for which one comes first. But right now, you're either going to have the name or you're going to have the structure. If you have the name, you have to write the structure. If you have the structure, you have to write the name. Keep them in the same order, right? So if I give you H2O, put hydrogen first. So the first one is literally going to be the first one I give you. So a prefix that tells the number of atoms of the first element present, and then that's going squished up right next to the elemental name. So if it's oxygen, you're going to say oxygen. If it's carbon, you're going to say carbon. If it's hydrogen, you're going to say hydrogen. So elemental name of the first element. So no modifying, no nothing. So if I have 2 carbons, I'm going to say dicarbon. And that goes together. That's going to be one thing. There's not going to be a space between the di and the carbon. So squish together. And then we're going to have a prefix. I'm going to write the same thing that tells the number of atoms, except I'm going to change first to second, of the second element. And then that's going to go squished up with the elemental name of the second element. But we are going to do that modified IDE ending again. Because the ending is not modified, the whole thing is modified. Right? So that was the whole first syllable thing. So if it's sulfur, sulfide, and so on. And then that gets squished together. So a prefix that tells us the number of atoms of the first element, and then the name of that element. A prefix that tells us the number of atoms of the second element, and then that modified name. So hydrogen, hydride, oxygen, oxide, and so on. I do have a couple exceptions. So I'm going to stick an asterisk on this. So my first exception, if one atom of the first element, and this is only for the first element. I'm not putting the asterisk over here. I'm going to write it, but then I'm going to get rid of it. I'm not putting it there. I'm only putting it on the first one. So if one atom of the first element, omit mono. If there's one element of the one atom of the second element, I'm not going to omit mono. Again, this is only for the first one. And then another asterisk that goes for all of it, so I won't put it up there. If the element name begins in a vowel and the prefix ends in an O or an A, omit the O or the A. So if you have one oxygen, and it's not the first element, because if it was the first one, I would just say oxygen, but it's the second one. So my second one, I have one oxygen. Instead of saying monoxide, I'm going to say monoxide. So actually, that's a really good example because both of our exceptions are on this one. So if I was to write CO2, actually just CO. So I have one carbon. Because it's the first one, I'm just going to say carbon, right? These are examples for my exceptions, right? Not monocarbon. I do only have one oxygen, but it's my second one, so I'm not going to omit it. However, oxygen begins in a vowel, mono ends in an O, so I'm going to say monoxide. Remember, I'm modifying that ending. So not monoxide. So both of our exceptions get used in that one example. So carbon monoxide. So let's do a couple other examples. We could do CO2, right? So I have one carbon because it's the first one. I'm not going to say monocarbon. We're just going to say carbon. And then I have 2 oxygen. We go up to our list here that you do need to memorize. 2 is di. So di is going to go right in front of my modified name for oxygen. So carbon dioxide. How about C2H8? So you can't have that, sorry. I just broke the octet rule. C6. So I have 2 carbon. So my prefix for 2 is di, it goes right in front of carbon. And then I have 6 hydrogen, 6 is hexa, and then hydrogen becomes hydride. This is actually an organic molecule, and once you get to organic, we're actually going to name it ethane, but using our rules for now, dicarbon hexahydride. Most students find that once you memorize those prefixes, naming organic molecules is pretty straightforward, because we're really just looking at what is the name of the element, how many of them do I have, you stick that prefix in front of it. So I have 3 phosphoruses, it's kind of funny to say, so tri with our prefix for 3, phosphorus. Remember, we're not modifying the first one at all, so phosphorus stays phosphorus. And then I have 8, so octa, and then fluorine becomes fluoride. Again, the U does come before O in fluorine and fluoride. So triphosphorus octafluoride. Going backwards, if I give you the name, dinitrogen, tetrachloride. So again, keep the first one first, the second one second. So I'm going to have nitrogen first. I don't have to worry about charges or anything like that because they don't have charges. And I know how many I have because that's what that di is telling me. So dinitrogen is N2 because di is the prefix for 2. And then chloride is chlorine, so Cl. And then tetra is my prefix for 4. So dinitrogen tetrachloride N2Cl4. How about, didn't mean to switch colors, I knew what I did. How about dihydrogen monoxide? So hydrogen is H, and how many of them do I have? Good, 2. Oxide is O, and how many do I have? Yeah, just 1. So dihydrogen monoxide is just water. So once you learn the prefixes, it's really pretty straightforward. You just have to remember those 2 exceptions. So prefix that tells the number of atoms of the first element, the elemental name of that first element, a space, the prefix that tells the number of atoms of the second element, and then that name, right, the first syllable of the element with the modified IDE ending. And then remember, if you have one of the first element, you're going to emit mono, not with the second, like down here, right, carbon monoxide, and then dihydrogen monoxide, right, I had one of the second, so I kept it there. But in carbon monoxide and carbon dioxide, I didn't put it with the first one. And then again, it's monoxide, not monoxide. Usually if it sounds pretty funny, there's a possibility that it's wrong. It sounds better when it's right, which I know is weird when you're learning, but monoxide doesn't sound as good as monoxide, right? So I think your gut would tell you that monoxide is correct. All right, acids next. And you guys are going to get the quickest definition of acids ever. We're going to spend more time in chapter 7 on acids. There's 3 common definitions of acids. In 152, you actually are going to spend almost 2 entire chapters talking about acids. But for us, an acid is going to be something that when we put it in water, it's going to donate a proton or lose a proton, H+. So it's going to lose H+ in aqueous solution. Aqueous solution just being a solution with water. And again, there's lots of different definitions. I'm kind of meshing definitions on this one, and we will go into more detail later. We just have to be able to right now recognize if something's an acid, right? If we're going to name acids, we have to know what an acid is. So if I was to take HCl and then I put it into water, it's actually going to separate into H+ and then Cl-. So Cl- is like losing H+. Because I'm putting in water, it's going to be aqueous. So how we're going to recognize acids is they're always going to have a hydrogen. I can't lose a hydrogen ion if I don't have a hydrogen ion. So they have to have hydrogen. So like PCl3 cannot be an acid using this definition. And then I'm going to put an AQ after it to show that it's an aqueous solution. So if I just give you HCl and put a G after it, versus HCl and put an AQ after it, this is going to be my acid. This is just a covalently bonded compound, right? That would be hydrogen monochloride if you were to name it. Remember, hydrogen's a nonmetal. I haven't given you how to name them, but this one would get named as an acid. So again, kind of our clue, I'm going to put an AQ after it, right? It's going to lose a proton in aqueous solution. So it's going to have a hydrogen. It doesn't necessarily have to be first. I will probably write it first until we get used to it. And then I'm going to put an AQ after it. So if you see something that has that general formula, we're going to name it as an acid. So our rules for naming acids are actually going to be based on the name of the anion. So if the anion ends, we're going to have 3 here. In IDE, let me write that so it's clear. So if the anion ends in IDE, our name is going to become hydro, and then whatever that anion happens to be, and then acid. So an example, that HCl example. So right when I separate it, if I go up, I have Cl-. So Cl- is my anion, and its name is chloride, and chloride ends in IDE. So it falls under this category. What we're going to really do is we're just going to replace that chloride with the rest of the name. So, I forgot part of it. Hydro, and then I need an IC at the end. Otherwise, it sounds really bad. Hydroic, that's an IC, acid. So the chloride part goes away, and then what's left, the chlor part goes in on that blank. So hydrochloric acid. So I put an AQ after it. I now know to name it as an acid. And it's going to be hydro. And then I'm going to take this part, chloric, right? I'm putting that chlor part on that line, and then acid. So hydrochloric acid. HCN, I have an AQ after it, so we're going to recognize it as an acid. Cn- is my anion. This was one of the polyatomic ions that you needed to learn. If you didn't learn them, then you wouldn't know that it ends in IDE, and you may name the acid incorrectly. But that anion is cyanide. Cyanide ends in IDE. So we're going to take this part, and I'm going to stick it back up on that line again. So the name of this as an acid, hydro, and then cyanic acid, right? If I go back up, I'm just taking that cyan part and I'm sticking it, oop, I spelt it wrong, but I'm sticking it there. So if your anion ends in IDE, hydro blank ic acid. Basically, we get rid of the IDE and stick what's left on that line. Our second, this is going to be if our anion ends in ATE. It's going to become ic acid, no hydro this time. So if the anion ends in 8, right, ATE, it becomes ic acid. So essentially you're going to replace the ATE with ic acid. An example for us, HNO3, right, this time my anion is NO3 minus, again another polyatomic ion. You do need to learn those. And nitrogen with 3 oxygens and a negative charge is nitrate. It ends in 8, so nitric acid, no hydro this time, right? I'm taking this part after I get rid of the ATE and I'm sticking it on this, right? So nitric acid. Essentially replace the 8 with ic acid. HClO4. ClO4 minus is perchlorate. This you would get from that second handout with the list of rules for naming other polyatomic ions. It ends in 8. So perchloric acid, right? We're getting rid of the ATE, we're replacing it with ic acid. So our second, if our anion ends in ATE, get rid of the ATE, replace it with ic acid. Our third one, and that's if the anion ends in ITE. So ite, it becomes OUS acid. So HNO2, aqueous, we know it's an acid. NO2 minus is nitrite. So ends in ITE, becomes nitrous acid. HBrO2, aqueous. BrO2 minus is bromite. So this becomes bromous acid. So if the anion ends in ITE, get rid of the ITE and replace it with OUS, so US acid. I do want to go through just a couple more examples where I mix up ionic, covalent, and acids, and we need to name them. So given something like this, kind of the first question is it ionic? Is it covalent? Is it an acid? Because we're going to name those differently. So when I'm given a compound, that's the first thing I'm thinking. And this one is going to be ionic. I have calcium in it, which is a metal. If you have a metal, for us, it's going to be ionic. Remember, covalent for us is going to be a nonmetal and another nonmetal. And then our acids, those are actually all going to be nonmetals also. The biggest clue for those, though, again, is I will put that aqueous after it. So this is going to be ionic. Remember, ionics don't have a metal, though. It could be between ammonium. That's really our only positively charged polyatomic ion that you tend to find in compounds that I'm going to give you. So ammonium and then some sort of non-metal. There's no metal there, so just watch out for those. So this is a metal. It is ionic. So then the second question is that if it's ionic and it has a metal in it, we want to know fixed or variable charged metal. Because we need to decide, does it need a Roman numeral, right? If it's fixed charged, I don't need one. If it's variable charged, I do. So we've decided that it's ionic, and then is calcium fixed charged or variable charged? What do you guys think? Good. Hopefully you came up with fixed. And then BO is one of our BO is one of our polyatomic ions. We actually could do boron, but I don't want to. Squish that R in there. So BRO is one of our polyatomic ions. It's one that would be on the list of naming patterns, and not one of the ones you memorize, but one of the ones that I would expect you to be able to name. So if you haven't gotten started on those, please do. So because it's fixed charged, I don't need a Roman numeral, so just calcium. And then if you haven't learned them yet, it's actually hypobromite. Another one. So same question, ionic covalent or acid, and SC is scandium, and it is a metal, so ionic. Our next question then, is it fixed charged or variable charged? So you'll want to find it in the periodic table, right? We know it's not aluminum, zinc, cadmium, or silver, but the question is it in group 1A or 2A? And it's not in either one of those groups, so we do need a Roman numeral for this one. And then remember, we're going to figure out what its charge is based on the charge of the anion. So PO4 is phosphate. It's one of those polyatomic ions, and it has a -3 charge. C then, I have one of them, right? There's one of these for every one of these. Remember, for ionic compounds, my net charge does have to equal 0. So what does my charge on scandium have to be? So when I add it to the -3 charge of phosphate, I get 0. Good, it needs to be a +3. So the name of this one, scandium, Roman numeral 3, because its charge is a +3, and then phosphate. Again, you do need to learn those polyatomic ions. How about, let's do HF, AQ. So ionic, covalent, and acid. It is covalently bonded, but I do have that AQ after it, so we're going to name it as an acid. And then we have to look at what is our anion, which is F- in this case, and we have to look to see what it ends in, and F- is fluoride. So this was the first rule we had for naming acids. Our name is going to be hydrofluoric acid. I do want us to be able to go in both directions. So carbon tetrachloride. So we know this is covalent. We have carbon and chlorine, right? Chloride is chlorine. So both nonmetals, but then also tetra. You're not going to see those prefixes with things that are ionic, right? Our rules for naming ionic compounds didn't say use prefixes. So based on the fact that tetra's in the name, I know that this is covalent. So C, how many carbons do I have in this compound? Yeah, just one, right? I don't have a prefix in front of it, so it's just one. And then chloride is chlorine, we already said that. And then how many chlorines do I have? Good, tetra is 4, so carbon tetrachloride is Cl4. Aluminum oxide. So when we're going in this direction, right, unless it's covalent, right, because remember if it's covalent, I don't have charges, I don't have to worry about it. If it is not covalent though, and I'm not going to have you do acids in this direction, so you don't have to worry about those ones, I need to make sure my net charge is equal to 0, right? Essentially because if it's ionic, my net charges need to equal 0, and we need to consider that when figuring out how many atoms of each we need, or how many ions of each do we need. So I have aluminum, it's a metal, ionic. And what's my charge on aluminum? Good, 3+. It's one of my fixed charge ones. We know it's fixed because there isn't a Roman numeral there. And then oxygen is oxide is oxygen, and its charge, -2. So remember, our net charge has to be equal to 0. So the question is, how many of each do I need? Well, if I have 2 aluminum, I'll have a +6 charge. And then if I have 3 oxygen, I'll have a -6 charge, and it adds to 0. You could do that crisscross we talked about, where this comes down and this comes over. Just be careful to reduce if you do that method, right? The real way to do it is that our net charge has to equal 0. So Al2, right, because I have 2 aluminum, and then O3, because I have 3 oxygen, would be the formula for this one. So please practice naming these, learn your polyatomic ions. There's lots of practice out there for you.